Liver. Histology. The liver is a vital organ within the human body and has a complex architecture that allows it to perform its functions as the metabolic master controller within the human body. The liver has many crucial roles, especially in glucose metabolism and detoxification of poisons. The liver, on a superficial level, can be divided into four main lobes: the right lobe, the left lobe, the caudate, and the quadrate lobes. These lobes can be divided into further lobules, which are the functional units of the liver. They are formed from a hexagonal cell shape which is arranged into rows. Here you can witness the portal triad, which is the collection of the bile duct, vein and artery that run in between these hexagonal cells and at each of the vertices, which allows a huge vasculature to run and perfuse the liver, further adding to its complex structure that allows it to perform its role. The hepatocytes are the primary functional cell within the liver and make up the majority of its mass. They perform various functions such as metabolizing nutrients, detoxifying harmful substances, and producing bile. Now looking at the sinusoids, which are specialized capillaries that run between these rows of hepatocytes within the lobules. Sinusoids receive blood from branches of the portal vein and hepatic artery, facilitating the exchange of nutrients, oxygen, and waste products between the hepatocytes. The portal triads, as mentioned, run in between the corners of each lobule and consist of branches of the hepatic artery, portal vein, and bile duct. They provide the liver with the oxygen, nutrients, and other essential substances for performing its many functions. The bile canaliculi also are the collection of the hepatocytes secreting bile into these small channels. They merge to form the bile ducts and are able to transport the bile into the gallbladder, where it can be stored, or directly into the small intestine for digestion. Kupffer cells are specialized macrophages located within the sinusoids and play a crucial role in immune defense by engulfing and removing foreign particles and old red blood cells. The liver is also surrounded by a connective tissue capsule called Glissen's capsule, which extends into the organ and forms the supportive structures within the lobules. This is what all contributes for the intricate design of the liver and allows it to efficiently carry out these vital tasks, contributing to the overall well-being of its body. Now let's look at the physiological level into the liver, seeing its metabolic role through detoxification and biosynthesis. Detoxification occurs primarily within the hepatocytes. Now, looking at the liver from a physiological perspective, let's delve into its metabolic role in detoxification and biosynthesis. Detoxification primarily occurs within hepatocytes, which is the main functional cell of the liver. This includes the first phase of detoxification, where hepatocytes use enzymes, mainly from cytochrome P450, to modify or break down toxic substances. This process often involves oxidation, reduction, or hydrolysis reactions. In the second phase, the modified substances from phase 1 reactions undergo conjugation. This involves attaching water-soluble molecules such as glucouronic acid, sulfate, or glutathione to the modified toxins, making them more polar and easier to excrete. The detoxified and conjugated substances are then transported into the bile canaliculi, small channels between hepatocytes. From there, they enter the bile ducts. Bile containing the conjugated and detoxified substances is eventually released into the small intestine, Some toxins are directly eliminated through feces, while others may undergo further processing in the intestines before being excreted. Bile synthesis. Bile synthesis primarily takes place in hepatocytes, and the bile then moves into the bile canaliculi. Bile is composed of water, electrolytes, bile salts, bilirubin, cholesterol, and phospholipids. Hepatocytes synthesize bile salts from cholesterol. Bile salts play a crucial role in emulsifying fats in the small intestine, aiding in digestion and absorption. Bilirubin, a waste product from the breakdown of hemoglobin, is conjugated with glucouronic acid in the liver, making it water-soluble and suitable for excretion. The components of bile, including bile salts, bilirubin, and other substances, are transported into the bile canaliculi. These canaliculi merge to form bile ducts that carry bile to the gallbladder for storage. The gallbladder stores concentrated bile until it is needed for digestion. Upon the ingestion of fatty foods, the gallbladder contracts, releasing bile into the small intestine to aid in the digestion and absorption of fats. Both detoxification and bile synthesis are essential for maintaining homeostasis in the body, regulating nutrient absorption and elimination of waste products and toxins. The liver's intricate architecture with its hepatocytes, bile canaliculi, and bile ducts facilitates these functions. Toxic substrates. Substances. Thank you for listening, and please make sure to like and subscribe. It really helps us with the YouTube algorithm and watching our previous videos so that they can be recommended to you for a greater learning experience and the ability for you to not only know the liver histology and anatomy, but also more into the field of medicine and also nuclear physics.
Thank you.